So today we're going to be talking about questions from the Thanksgiving assignment. All right, so let us look at the first question here. So y is equal to x squared times e to the x. We want to find the derivative of y against x. Now, of course, what we have to do is using the product rule because this is the product of two functions. So first, what we end up getting is, let's take the derivative of x squared, which becomes 2x multiplied by e to the x, plus keeping the x squared as it is, multiplied by derivative of e to the x, which will be simply e to the x. That's what we end up getting. Now, then when you factor out the common factors here, which is x e to the x, then we are left with 2 from the first term plus x from the second term. Should be choice C. All right, let us look at the second question. Domain of the function. Domain of the function, in fact, has a few components. One thing is that denominator cannot be equal to 0. Now, but inside of the radical, for the real numbers, this one has to be greater than or equal to 0. Now, in order for us to satisfy the denominator, then x cannot be equal to 3. That's one condition. How about this one? X squared minus 4 has to be greater than or equal to 0. In order for us to solve this one, basically what we end up getting is x has to be, or let's try to do this one. If you were to apply x squared minus 4 is equal to 0, which equation will get us the boundary of the inequality. Now here then we end up getting x squared will be equal to 4, where x will be plus or minus 2. Then using a number line, you will realize that minus 2 plus 2. We are looking for this section to be positive, but if you imagine graph, graph of x squared minus 4, you would have gotten something like this. Meaning, the inner portion becomes the negative because below the x-axis. The outer portion becomes positive. And we are looking for positive sections, so therefore, we are looking for this way. Meaning absolute value, this simply applies for absolute value of x has to be greater than or equal to 2. Except x cannot be equal to 3. So what we are looking for is choice D. Now, concave down, that means second derivative has to be less than 0. So let's try to go for that one. What is y of the first derivative? In fact, you can assume this one is negative 5 times x minus 2 to the negative 1 power. So when you take the derivative of that, we end up getting 5 x minus 2 to the negative 2 power. So therefore, when you go for second derivative, then we end up getting negative 10 times x minus 2 to the negative 3 power. If you want to write this one as a fractional format, then we end up getting negative 10 over x minus 2 to the 3 power. Of course, this will never be equal to 0, but where this one is not defined is when x is equal to 2. So for example, if you had to use the number above 2, such as, how about 3? When x equals 3, we realize the concavity here. Numerator is always negative, but denominator is positive, which gets us negative. When x here is equal to 1, then top and bottom are negative, so which makes the positive. Now, concave down, we are looking for negative section. So therefore, our area will be x has to be greater than 2, which is choice C. Alright, in this case, you have to take the derivative of this. You can use the quotient rule. Then first denominator has to be squared. and denominator times the derivative of the top, which is 1 over x, minus top times the derivative of the bottom, which will be simply equal to 1. If you have to simplify this one, x times 1 over x becomes 1 minus ln of x over x squared, which becomes choice D. Alright, let us move on. Here we have first derivative has to be positive. That means it has to be increasing. The second derivative has to be negative. That means we are concave down. So if you think about it, this is concave down. Given that we are looking for increasing portion of the negative concavity, we are looking for anything that looks like this, which seems to be right here between B and C. Then 2 only will be our answer. Alright, so in this case, we have implicit differentiation. We have to take a derivative, and then we have to plug in 1 comma 1. Here, derivative of x becomes simply 1 plus 2 times derivative of x times y. We have to use the product rule, x times y prime plus simply y times x prime, which is equal to 1, minus 2y by the chain rule, and implicit, we end up getting y prime, which is equal to 0. Once you plug in 1 and 1 in place of x and y, we end up getting 1 plus 2 times y prime plus 1 minus 2 y prime is equal to 0. Then here you will realize that 2y primes will cancel out, and only thing that's left is 3 is equal to 0, but we know that that's not possible. So therefore, y prime doesn't exist. Here we're looking for line tangent to the graph. Then line tangent, that means we need slope and the point. We already have the point. The only thing that which we need is the slope. How are we going to find it? Slope is found by first derivative. Once again, using the product rule here. So x times 3 times 1 minus 2x squared, and then derivative of the inside, which ends up being negative 2. And then plus the other portion, 1 minus 2x to the third power times the derivative of x, which is equal to 1. Here x value has to be equal to 1, then we end up getting, here this is 1, then inside here becomes 3 times 1 minus 2, because x equals 1, square, which ends up being 1 times negative 2. Here also becomes simply, in this case, 1 minus 2 becomes negative 1, put to the third power becomes negative 1. So what we end up getting is negative 7 becomes our slope. So only thing that has negative 7 as our slope will be choice A. Now here we have to take the derivative and then plug in pi over 3. So this becomes cosine of pi over 3. Cosine of pi over 3, in fact, we know that to be 1/2. So therefore, our answer becomes simply 1/2. Now here we have to take the derivative of this. If you have to take the derivative of that, because we can assume that this one is equal to 2x to the 1/2 power, then we end up getting 1/2 times 2x to the negative 1/2 power multiplied by what's inside, derivative of 2x. 2 cancels out with this one. So what we end up getting is, because of negative, 2 times, in place of x we gotta plug in 2, so we end up getting 1 over 2. Alright, here we have to take the double derivative. So y prime first becomes 2 times derivative of cosine becomes negative sine, and x over 2 times the derivative of inside, which is 1 over 2. And that cancels out with this one. Therefore, when you take the second derivative of this, it becomes negative. Derivative of sine becomes cosine of x over 2. And then multiply that by derivative of inside, which is 1/2. So we get negative 1/2 cosine of x over 2. So it seems to be negative 1/2. Choice E becomes our answer. Here, what are we going to get? In fact, negation of the logarithm can be expressed as ln of x minus ln of x to the negative 1. In fact, 1 over x is x to the negative 1 in exponential format is equal to 2. But by the power rule, negative 1/2 will come to the front. It becomes ln of x plus ln of x equals 2. Then obviously ln of x equals 1. But then what value of x will ln of x be equal to 1? Then x has to be equal to e. Now here we have, we can say y equals x to the ln of x. Now what we can do is to separate bottom, the base, and then exponent, we can use ln, logarithm. Then this can, by the power rules of the logarithm, it can come to the front. So we end up getting ln of x times ln of x, which is equal to ln of x squared. Now, if you take the derivative of the left side, we end up getting 1 over y times y prime by the chain rule. And then here we get 2 times ln of x times derivative of inside, which is 1 over x. Then y prime then becomes, here we have 2 ln of x over x times y, which was in fact x ln of x. Then here our answer becomes choice. Choice C. All right, let us move on. Here, when you look into this one, you will realize that choices are continuous and differentiability. Those are what we're looking at. So, in order for us to see the continuity, what we continuity is that basically that means f of 3 has to be equal to limit for the function f of x as x approaches 3. Now, what is f of 3? Then that can be calculated from here, which is simply equal to 6 times 3 minus 9, which is equal to 9. How about limit as x approaches 3? In order for us to evaluate that, we need to get the both sides. Is that in fact equal as x approaches 3 from the right versus, due to space, I'm just going to write this one, from the left for the function f of x. Then you will realize that from the right becomes greater than 3, so we'll be using the same values, same expression, which is equal to 9. From the left, that means earlier one, which is 3 squared, which is 3 is equal to 9. Therefore, yes, it is continuous. But how do you figure out the differentiability? Differentiability is simply the definition right over here. Is this defined? As h approaches 0, but in place of x we have 3 now. So what I can do is I can, in place of x, I can put 3. But this basically means we have to have left and right limit to exist. That means we have a limit of the f of x, 3 plus h minus f of 3 all over h as h approaches 0. Now, this one has to be from the positive. The other one is same thing but from the left. Now that means if h is positive, then we are looking at the expression that's greater than 3. So we're looking at the slope from the right side, right over here. And slope, meaning slope in this case, because this is difference quotient is essentially the slope. So therefore, here we end up getting the derivative of f of x when x is greater than 3. We end up getting simply 6. On the other hand, when h is negative, then we are looking at derivative of x squared, which is 2x, but x is equal to 3. And yes, it is also differentiable. Therefore, our answer is both continuous and differentiable will be our final answer. All right, here, this is the definition of the derivative. Obviously, this portion is the f of x. Then what is the derivative of tangent of 3x? Derivative of tangent becomes secant squared. And then you have to write down as it is, 3x, multiplied by derivative of inside, which is 3x. Derivative of 3x becomes 3, so we have to multiply by 3 at the end. And our final answer seems to be choice B. All right. Inverse function. What is inverse function? We simply have to switch x and y, as you guys have done earlier. Here y equals x over x plus 1. But when we switch x and y, we end up getting x equals y over y plus 1. How are you going to simplify this one? Why don't I just flip each side? Then I will end up getting 1 over x, which is equal to y plus 1 over y, which I can simplify this one as 1 over x, 1 plus 1 over y. Then when I subtract 1 from each side, then I get 1 over x minus 1, which in fact, if you have to simplify this one, it becomes 1 minus x over x, which is equal to 1 over y. To solve for y by itself, y will be equal to x over 1 minus x. And you could have done this one in many different ways, but this would be one of our answers. Choice C. Alright, let's look at the absolute maximum. So as you see the word absolute maximum, you have to look at the endpoints and also critical points. So to find the critical point, we have f prime has to be equal to 0, or undefined for that matter. Here we have that's equal to 3x squared minus 6x. When you factor out 3x, then we are left with x minus 2. Then we realize that the values which we have to look for is when x equals 0 or 2. But considering the endpoints, what we end up getting is x. Y value has to be negative 2, endpoints, and 0 to another endpoint. So when you plug in negative 2, what will we end up getting? When you plug in negative 2 here, we will end up getting negative 8, and then it becomes negative 12, positive 12, which ends up in simply negative 8. When you plug in 0, it becomes 12, which is nice. When you plug in 2, it becomes 8. And when you plug in 4, we end up getting 64 minus 48 plus 12. So that in this case, we end up getting 28. So therefore, what is our absolute maximum? Absolute maximum becomes 28. Now, then x in that case will be equal to 4, right over here. Alright, so let's look into this one. Which of the following must be true? The fact that the limit is equal to 7, in fact, it doesn't guarantee that it's continuous. No differentiable, because it can be this, there can be a hole in the graph also. Still, we can find out the limit. F of 3 doesn't have to be equal to 7, because once again, the hole in the graph could be the region in Y. So therefore, none would be our answer. All right, with that, we talked about number 17. Let's go for a couple more questions. Number 18. Which one of the equation has y equals 1? That's the asymptote. Horizontal asymptote, basically, that's what we end up getting. Horizontal asymptote is the limit of the function as x approaches positive or negative infinity. Now, as they're going to positive or negative infinity, which one will be equal to 1? In fact, only answer that's possible is choice C. Here, because the graph is keep on going up, infinity, here it will fluctuate, hence do not exist. Here, in fact, as x approaches infinity, because exponent of the numerator is greater, it will approach infinity. And then here we will end up getting the graph, exponential graph, in fact, will become like this. Therefore, it will approach 0. So our answer will be choice C. All right, number 19. F and g are both odd functions. Then what's going to be happening? Here we have p of x. Then what we have to do is we got to plug in p of negative x, see what happens. And there will be f of g of negative x. But since g is the odd function, you will realize that that's equal to f of negative g of x. But since f is also odd, that will be equal to negative f of g of x. So in fact, you will realize that when you plug in negative x, you get negation of the original function. It's an odd. How about here? R of negative x becomes f of negative x plus g of negative x. Since both of them are odd functions, we'll end up getting negative f of x minus g of x. But when you factor out negative 1, you will realize that negative f of x plus g of x, which is negation of the original function, hence that is also correct, first and second. How about the third? S of negative x becomes, yes, f of negative x times g of negative x. But since both of them are negation, odd function, we will end up getting negative f of x times negative g of x. And negative becomes positive, so which we end up getting simply f of x times g of x, which is same as the original. Then in fact this becomes even function. So first, second work, but not the third. And our answer is choice C. All right, this is end of part 1. We'll talk about part 2 later. Have a nice day. See you guys later.